In this video, we'll be using the quadratic formula to solve a couple of quadratic equations. We'll also be discussing some characteristic properties of square roots, not a lot though, but we start here and end it in the next one. But before that, I'd like to do a quick review. In the first video of this playlist, quadratic equations were defined. We also talked about the general form of quadratic equations, and two important questions were answered. Why is it that the value of a cannot be equal to 0? And why the general forms never have negative signs? Then there was this short informative video called Methods of Solving Quadratic Equations, where I introduced the three major methods of solving quadratic equations, namely the factorization method, completing squares, and the formula method. We also discussed the trial and error method, by the way. The third video was a comprehensive video on the method of factorization. That video has some of my special tricks that make factorizing a quadratic equation a walk in the park. The fourth video was on the method of completing squares. I discussed the algorithm step by step. Also, the quadratic formula was derived as a bonus here, just in case you're interested. Then the fifth video was a screencast of me solving a couple of quadratic equations using the method of completing squares. And now we're here. In this video, we'll be solving these quadratic equations using the quadratic formula. What this formula does is it takes certain values from the quadratic equation, namely a, b, and c, and it gives us the roots of the equation. Pretty neat, right? Because there is no guesswork involved, like the method of factorization. We have a quadratic equation here. We want to use this formula, but we need the values of a, b, and c. So, we need to bring this equation in the general form ax squared plus bx plus c equals 0. Let's move these two terms from the right side to the left side while remembering the fact that such an operation changes the polarity of the terms. Now, we know that a is 3, b is 8, and c is 3. Let's plug these values into the formula. We have negative 8 plus or minus under root 64 minus 4 times 3 times 3 all over 2 times 3. 2 times 3 in the denominator becomes 6, and inside the radical we have 64 minus 4 times 3 times 3, which is 64 minus 36, which in turn is 28. So we have negative 8 plus or minus root 28 all over 6. You could technically leave it this way, but I am pretty sure that most instructors would want you to simplify this radical and show the fact that you are comfortable with the algebra of radicals. Root 28 is 2 root 7. A quick side note here. Under the root, we can write 28 as 7 times 4, then we can separate the two numbers like so. Root 4 is 2. Well, it is plus or minus 2, but that fact is accounted for because the quadratic formula has a plus or minus symbol. Now we can leave the answer like so, but why wait when you can go further? You can factor out a 2 from the numerator like so. Now this 2 over 6 can be reduced to 1/3. So the answer is negative 4 plus or minus root 7 divided by 3. Incidentally, if this plus or minus sign is new and alien to you, what it means is exactly how we read it. It represents that we could have a plus here or a minus. So we can write both the roots individually like so. The same is true for all the steps here. We could write all these steps with individual signs, but it becomes repetitive and tedious very quickly. So we use the plus or minus sign. Quick recap of the steps we performed. We brought the equation in its general form to find the values of a, b, and c and then plug them into the formula. With more practice, you'll be able to identify the values of a, b, and c without these steps. But keep in mind that if you make even one mistake in identifying the values of a, b, and c, everything afterwards will be incorrect, even if you do these arithmetics correctly. After identifying the values of a, b, and c, we plug them into the quadratic formula. You may be asked to memorize it, or you may be allowed to bring it in the test on a note card. Whatever the case may be, I, a passionate mathematician, recommend that you commit this formula to memory. After that, we simplified the equation to get two roots. let's move our attention to the question. This question could have framed the exact same equation differently and the solution would still be the same. The equation could have been x squared equals negative 8x minus 3 all over 3. Or it could have been x squared equals negative 8/3 of x minus 1. We would still bring it in the general form, which looks like so, and then apply the quadratic formula and get the same roots. With all of that out of the way, here's another quadratic equation. I want you to pause the video and solve it using the quadratic formula. As an additional challenge, if you want to solve it using factorization and completing square, you're welcome to. But first, you must solve it using the formula. I hope you solved it. As a checkpoint test, let's see if you got the values of a, b, and c correct. A is 7, b is negative 5, and c is negative 2. Now let's check the final answer. It is 1, negative 2 over 7. Irrespective of whether you got the answer, if you tried to solve, then I want you to take a moment to be proud of yourself for actively participating in self-improvement. Here's the solution. To bring it to the general form, multiply all the terms by 7, then move these two terms to the left side. Now we can get the values of a, b, and c, which are 7, negative 5, and negative 2 respectively. Plug these values into the quadratic formula. We get negative of negative 5 plus or minus under root the square of negative 5 minus 4 times 7 times negative 2. And in the denominator we have 2 times 7, which is 14. Negative of negative 5 in the numerator is positive 5, and then under root negative 5 squared is positive 25, and negative 4 times 7 times negative 2 is positive 56. 25 plus 56 is 81. Square root of 81 is plus or minus 9. We have to segregate the numerators now. 5 plus 9 is 14, which divided by 14 is 1. With the minus, we have 5 minus 9, which is negative 4, divided by 14. This simplifies to negative 2 over 7. Before leaving, I want you to take a look at this. The first problem that we solved, we got these two roots, which if you look carefully are conjugates of each other, whereas the roots of this problem are distinct. Time to put your brains to work and think what causes the roots to be conjugates versus distinct. There is also a third possibility where both the roots are essentially the same number. Try to think about it. I will be discussing this in the next video. If you enjoyed the video, then consider giving it a thumbs up and subscribing. Thank you.